Hello, everyone, and welcome to Passive House Accelerator Live, where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to the impacts of climate change. I'm Zach Semke, director of the Accelerator, and I'm excited to welcome Kristina Held to present about Nevils Creek Net Zero Passive House for this construction tech episode of Passive House Accelerator Live. Today's co-hosts are Sean St. Amour, Mark Willey, and Shannon Pendleton. And with that, Mark, please take it away.
So welcome everyone. Mark Willey. The favorite part of all my weeks is when Passive House Accelerator is live to see all your wonderful faces. And whenever we get those favorite words of net zero connected with Passive House, you could bet there's more fireworks in store. These local examples allow us to make more global results. Local examples make global results. Please take notes. Please applause and be kind to your fellow participants and get ready because Sean St. Amour is live at a Passive House somewhere in British Columbia. Over to you, Sean.
Hey, Mark, thanks for the pass. And hey, everyone, Sean St. Amour here. And yes, that building right there is about to have a blower door test. So because it's a bigger building, there's going to be a lot of the red doors of truth in there. But always exciting to be here. And let me just pull up the bio. So Kristina Held is the founder of Held Architecture, a Charlotte-based firm focused on sustainable and regenerative design. With over 20 years of experience, she became Charlotte's first Passive House certified consultant in 2019 and has led projects like the Canary Pester Pack US HQ and the city's first pre-certified Passive House. Kristina holds advanced degrees from UNC Charlotte and University with additional studies in Belgrade. Her holistic approach blends energy efficiency, functionality, and the beauty to create lasting, eco-conscious spaces. So, Kristina, let's fire up construction tech, where we get nerdy, where we have lots of fun, and of course, we only have fun with a PH. Kristina, over to you.
Hello, everybody. Thanks for having me. And I thought that we were going to play a video now of the house. It's a 3-minute and 30 video, and then we can dive right into the presentation. The whole house is really beautiful. It's in Nevils Creek, and the house sits on 30 acres.
The house is perfectly oriented east-west and true north and south to maximize the solar gain through the day. There's a 45 kilowatt lithium-ion battery bank that's accepting that solar charge all day long. My background is building high-end custom yachts. These yachts have the exact same systems that we've utilized here in this passive house. It's immaculate engineering. The initial vision for the project was to create this modern black barn behind this wood facade that looked like one of the old North Carolina tobacco barns.
The whole idea of the lattice is to have a passive architectural form that will prevent direct sun hitting the window. And the lattice is probably something that we worked the most on because it had to be not too dense and it had to be dense enough to block out the harsh summer sunlight. Another functionality was to have an outdoor space where people can move, like an outdoor corridor. You're still very much in tune with nature and how the sun moves around the house, so that's exactly what we wanted to achieve.
The windows are a revelation. You can sit in direct sunlight if you can find it, and it's comfortable because the window is actually reflecting that sun's energy. You're so well insulated that you need a lot less energy to heat and cool the space. The passive house is not only energy efficient, but it is super healthy. The envelope is fully sealed, but the air inside the home is constantly renewed with new fresh air that's filtered.
The walls are actually 3 walls in one. we used an Intello membrane, which is an intelligent vapor barrier. That means it's airtight, but it will allow vapor to move in both directions.
The organization of the spaces is brilliant. The living space feels like you're in a treehouse. It's a space that makes you feel secure. It makes you feel relaxed. It makes you feel refreshed. It's light and airy and a lot of white oak, and it's so well done, you never really feel motivated to leave.
You can always see from south to north and vice versa. So wherever you stand, you actually see nature and you feel like you're right in the middle of it.
When you live in a passive house, you find much more energy. You find much greater comfort. What Kristina's done here is develop a beautiful living space.
It's the connection really to the environment that makes the house really beautiful and makes the people really happy.
All right, beautiful introduction with Kristina. With that, please take it away. Looks like you're muted, Kristina.
There, unmuted. Thank you. So I'm starting with one of the initial sketches, and that is always exciting when the initial sketch actually looks very much like the final product. So it's an FYI here. And this is just a slide about me. So what we do, so Held Architecture does sustainable design and planning for all types of residential and mixed-use projects, including adaptive reuse and office. So we do passive house also as consulting for bigger commercial projects, and we have used passive house design principles on projects like the office building in Huntersville. So here are some of the projects we have worked with in the Southeast, because this is about the Southeast, and it's not as prevalent to be building passive homes in the Southeast because we have a mild climate. Although our winters, I have to say, are getting harsher, and we have a lot of humidity in this area, and some of the summers can get extremely hot. So passive houses are really great in keeping the internal temperature of the house steady and giving you that user comfort that you need with high fluctuations of temperature between winter months and summer months. So like you see, these are all over North Carolina. We have one in Matthews. We have one under construction in Charlotte, which would be the first certified passive house in Charlotte. And we just got certified, full certification for the passive house in Davidson. That is not a net zero, but it does have a solar array on the other side of the house. We also worked on Bexaw, Matthews, Carlisle, and South Carolina. And we use different methods to construct the walls for each of them. And as you can see, the style is varied. That's why I picked those examples. We have from traditional to very modern, farmhouse, arts and crafts, and traditional styles. And so it very much, you can do passive house in any form you want. This project was the first passive house we ever did. So we are really proud of it. And the client was, it is a really special client as well, because he likes building himself. He's a custom yacht builder. And he was inspired by the traditional form of tobacco farms in North Carolina. And maybe he liked it because it's a very monolithic form, and the proportions, if you would turn it around, sort of look similar to a ship hull. So it might have some association there. And let's see here, just I have, so here are all the people, the whole team that helped make this project a reality. So I was the CPHC lead and architect. Roof modeling was done by Steve Schreiner. He's also a CPHC. Mechanical design was done by Wally Ray, who's a professional engineer with TLC Engineering. Scott Westmoreland did structurals with Solid Rock. And the builder was David Sawyer Homes. And all the beautiful windows are Schuko windows, and they were imported to the United States by Baubach. So the project started with the client calling me through the Find a Professional website through FIUS. So that was really great. So we had a conversation, and he said he already has land, he already has plans, and all he needed was to convert these plans into a passive house. So there is more to passive house than just running the Buffy model. So we did some rearranging to group the toilet rooms better and to also bring forth that facade that he was inspired by so much. So what we did is we created this lattice structure in front of bigger window openings. Before they were very small windows, and also tried to have the master bedroom and the living room have as much daylight and outdoor views as possible. But the general proportions of the building stayed the same. We also enclosed the boat storage and the garage and created a conditioned entrance space with a nice stair going upstairs. So first, what we do, what I'm sure everybody does when they do passive house, they also incorporate some of passive solar strategies. So the long axis is east-west, with the long facing south being shaded and the north side being just exposed to diffuse northern light. The angle of the roof has been determined by the best suitable angle for North Carolina for harvesting solar energy. So that's how we got the roof pitch. And it actually turned out a really monolithic, simple structure where you have the black core and then the lightweight wood structure hugging it. And the landscaping is also really beautifully done. When we first saw the site, it wasn't as cleared and manicured like it is now. And you actually were not able to see the water. Now they cleared all the small branches and the lower brushes, and you can see the water, and it's really beautiful. This is the north side. So just so you see how we treated each side differently, depending on what sun exposure it has. So the north basically doesn't get any shading. It has diffused light all through the day. It has beautiful large windows for daylighting and even the bathroom. So there's really not a room in this house that doesn't have daylighting, which is really important just psychologically. You can just move through the house and you don't have to turn on a single light switch. It's pretty nice. And then this is the south with the lattice, which has been designed to be just so to let enough daylight in and also block out the harsh summer sun. Over the exit for the master bedroom, we made the roof dense, so you actually have cover from rain and elements. And on the east side, you have a covered porch. So also what's nice about it is that you have in the kitchen, you are greeted by the morning sun on the east. And then as you retreat to the bedroom, you actually have views of the sunset, which is pretty nice. And I just have some stats because I know there are a lot of technical people here. They want to know how many kilowatts would generate. So he has an 8 kW on the roof for about 2,000 heated square footage is the house. And he can add 45 kilowatts, he can store that. But this is just directly from the client, actually in an email he sent me yesterday, asking for the presentation. So he says that it's about 22 kilowatt an hour in spring and fall, and about 28 during peak heating months, which is really good. So on average 20 kWh daily, which is really excellent, I think. What's also interesting for this house, I'll just add this, that the whole house is wired with marine cable, and it was wired by one of the client's electricians. So it's really safe. If it ever gets underwater, all the wiring will be safe. Also, the electrical panel is one you would find on a boat and not in a house. He combined DC light fixtures and ceiling fans directly to the battery pack. So that way you don't lose in conversion. So you can run it directly on direct current versus switching to AC and then back to DC again. He also has a backup generator, but he has not used it yet. This was like if he doesn't have enough energy, if the battery packs fails, but to this day he didn't have to use it, which is really good. The house is completely remote. It sits on 30 acres. And the only option was to do net zero. It is on well and it is on septic, and it runs solely on the 8 kW solar array that you see here on the south side. This is the west side. So in North Carolina, we get the harshest sun in the west, and we try to minimize openings on the west, and it does really help with on commercial buildings with that strategy as well. And the best bet is to get northern light, to get southern light that is sensibly shaded, because you get that warm light from the south. You still need it, although you can't hide from it, or you shouldn't. This is the east porch, which is completely screened in and it has a beautiful quality. It feels like a tree house sitting in it. And then I'm going to try and just flip maybe through the construction set. So for those who haven't seen one, I maybe just quickly share. Let's see. And I'll just quickly through it from the beginning, maybe. So this is about the certification process as well. So for pre-certification, we submitted the entire package with specifications, structural, mechanical, detailing, the whole set. So it is a pretty extensive set, and that's why I really appreciate the Passive House Institute, because as an architect, you can get a peer review of all the detailing, and they really carefully review it. And then when you get a comment, you're like, aha, yes, that really needs to be changed. So for this house, we got an interesting comment for isolating the garage. So we did this with EPS, I think, with rigid insulation. And the comment was that we really shouldn't completely seal it, because if anything leaks, moisture wouldn't be able to trickle out and it could rot the structure without anybody knowing. And it could potentially be a structural hazard. So we changed it and did mineral woven Intello between the garage and the living space above. And then, just worked out details, how to attach the catwalk through the rigid insulation to rim joist closed cell foam to get no thermal bridging there. And yes, that is the set all the way through the end. And even some interior design for this. And then you also get Dropbox folder where they are pre-made folders for you to fill in. And all of these categories basically have to be answered. So there's a lot of information you submit for pre-certification. And it's really nice because, like I said, you get the peer review and get another set of eyes to look through it. Here are some simplified floor plans. So you can see the long catwalk around and also the openness of the structures with vaulted ceilings in the living room and the master bedroom. And here is a cross-section of the house where you can see the continuity of the insulation going all around. And we have some CMU walls on the first floor around the garages. And then it's 2x6s that create the rest of the structure. And we were just trying with the Intello to be our air barrier on the inside. And we had a Mento wrap on the outside of the 2x6s, 2.5-inch electrical chase, and then on the outside, a rain screen. So this house was built during COVID, so they couldn't find the mineral wool at all. So they wanted to substitute it. And I really wanted to stick with rock wool. So we had less before. I think we had like 2 inches only that was needed. But then they had leftovers from a big commercial project, and the only size they had left was 3.5. So we used it, and that's how we got a little bit more insulation in it. And it's such a small house, so it was perfect. Just what got left over was perfect for the house. Here's also how we dealt with the continuous insulation from slab and the CMU wall. Up here. So in the south, what works really well is when you can combine mass walls with continuous insulation. That will effectively, if you have 2 inches of rigid insulation, it will effectively operate as 4 inches, just because the thermal mass really helps keep the heat in, air conditioning in. Some other sections. Really use the Intello barrier here because everything was fluffy insulation, and it was very breathable with the combination of Mento membrane and Intello air barrier. On other homes we use zip, And with zip, we do not recommend or haven't used the Intel air barrier. It would be too dense, too tight off. Here's some construction photos. And again, the sketch, it looks pretty similar. Here is the mineral wall going up, and the stucco is on the first floor CMU, and the structure is going up for the lattice. Solar panels are already on, everything going according to plan. And here are some other construction details we shot just to show how the continuous insulation actually separate that catwalk from the CMU and from the insulation. Here is the heated area, insulated, other picture, Intel. And since the house was remote, this was a long process of building it. So that is that difficult with homes that are very specifically built. Also, the gutter was almost an internal gutter. I mean, you don't see it from the outside, but it is outside of the envelope. So that was interesting to construct, but they did it, which is amazing. And just for mechanical, we started with what everybody uses on a passive house, what is given and recommended for exhaust and for CFM per person. And we had a mechanical engineer draft the mechanical drawings for us. We ended up putting the mini split and dehumidifier in the attic space. There is a ladder right here, we'll fetch, and have some exposed ductwork in the master suite and the living room in the vaulted ceiling areas. And in the first floor, we kept the ERV, and it had smaller ductwork, so that fit within the floor joists. We'll get to that. And this concludes the presentation. So when we filmed, the cat was following us everywhere, and it really enjoys the catwalk. So it's actually used by a cat, so really like it.
Great. All right. Our first question up is from Stephen Stone. Stephen, are you with us? And would you like to unmute and ask your question? Looks like you're here.
Yeah, beautiful building, very well laid out. I like it a lot. And the question was in the sketch, you had, it looked like the lattice work on the outside lifted up like an awning. Did that actually end up being a feature or something that was thought about but became impractical?
It was something that was thought about and became impractical. It was just too much to add that complexity because, you know, we're just trying to get done, I think. But it comes from the original tobacco barn, which, you know, you can raise the flaps up so you get more airflow through to dry the tobacco. So, yeah, it's also interesting that the tobacco barn was the inspiration because when you think of tobacco, it's very bad air quality, right? It's not good for your lungs. But then we have this house, which is superb indoor air quality. So it's like, it's interesting.
Great, thank you.
Thanks, Stephen. Our next question up is from John Roundtree. John, are you still with us? It looks like you might be here. If you're not able to unmute, I can ask your question for you. All right. He was just curious about what material the lattice is, Kristina.
Oh, it's epay wood.
Oh, lovely.
Yes, so it's going to fade a little bit. It looks still very warm on the pictures. It's not sealed, so it will eventually gray out, but it's very stable dimensionally, and it's not checkered or anything. It looks really good, yeah.
Yeah, it looks beautiful as brown, but that gray will become that nice light gray. I love the color that epay turns. Okay, wonderful. Well, our next question is from Justin Taylor. Hi, Justin. Welcome. Would you like to unmute?
Shannon, it looks like he is unable to come on screen.
Oh, perfect. Thank you. So Justin asks, were there any regulatory pushbacks in having the house completely off-grid and specifically electrically off-grid?
No, that went very smoothly. So we had no issues at all, not even with the boat electrical panel. That was all accepted. And yeah, it's a small community and they saw quality work and they had no problem with it, which is great. Yeah.
Great. And Rashad, it looks like you already unmuted. So why don't you come on and ask your question?
Is my mic working?
It is. Hello. Welcome.
Hey, my name is Rashad Hassan. I'm an architectural designer from Charlotte. And I was wondering, in your house, in your work on the passive house, there's a clear sensitivity to the landscape and seamless integration between the structure and site. And I was wondering, how do you approach when you're balancing the aesthetic vision with the environmental and cultural context, and how does that philosophy sort of shape the broader mission of your firm?
That's a great question. We really love to work with the grade and with landscaping. If you're in the city, it gets a little bit harder because you also have the street and setbacks and sidewalks and, you know, tree lines to take care of. But I think a lot of the architecture is exactly that. How do you respond to the context, be it nature or be it other buildings that were there before you, culturally, like you said, and also architecturally. So every project is different. It's hard to answer like with the formula, but I can only say that if I was supposed to design a house in a vacuum, I would not know how to start. So we start with the context wherever that is. That's like the first thing, like what are the grades, where are the trees, where's the water, where are the views, where's the sun, of course, most than anything. So yes, it would be for us impossible to design. Like I really literally wouldn't know what to start. Yeah. So
Do you have any
great
advice
question.
for young architects on how to get better at designing for the context of the site?
Yeah, start with the context. When you do an existing building, start with the existing building. Record everything. So when you start the project, that's what we do. What I would advise maybe is to go and collect all the data. So you go and you see the grading, the site, the quality of soil, views, where the sun is coming from, what your context is, everything. And then also talk to your client. Talk to the client in a way to just listen. So just ask questions and let them lead the conversation. And that's usually our first conversation. We do a lot of listening. And they might not know to tell you what style they want or how they want the home organized, but you can sort of sense it through the way they speak, what's important to them. And then that's really fun when you then do the project and they like it immediately, but that's usually because you listened. That's why it works. So yeah, so there's an architect in Switzerland, I think Olivieri is his name, and he says that you can be only so much creative, but like the universe is much more creative than all of us. So that's the context for me. So it's like an algorithm you try to solve, and the house or the building is sort of the answer to all of those data inputs. So that's why I say when it's a blank slate, you don't know what to design. So that's sort of like creativity comes from the context, I think, and from what was there before and how it informs your design. So just use it, just jot it down and start sketching, and it will be a good project.
Thank you so much
Rashad.
for the well thought out answer.
You're welcome.
And thank you for the question, Rashad. I think
Great question. Yeah.
Yeah, great question. And you got some really nice likes on and hearts on your answer, Kristina, from Bobby Warren, especially. Thanks, Bobby. You know what I love about Passive House and how much this community shares, and really what you did in your presentation today to show the details, to talk about, you know, design ideas that came and were tested and were altered. I think as a community care more about what we're required to care about, right? We're required to care about the energy use, the hot water, the exposure, the shading. But I love that you talked about the context and the client so much, because I find that, you know, we understand what Passive House wants, but the client doesn't have to understand that, right? They only need to understand it as much as they want to. And I'm curious, did you have any historical context or any site context about what was there before the house that you took into account as well? Did you have the water there and the climate, of course, but...
Yes, so there was nothing there before. It is just trees all around, and close by is a hunting ground, and just next door is a natural preserve. So there's literally nothing there, nothing. You would drive from the house probably good 10-15 minutes to get to any sort of civilization. And then the closest town is Washington, North Carolina, which is just your typical, you know, they have the typical Main Street traditional buildings. So So no, architecturally, there was really no context to draw. Well, just nature.
Great. Well, and I have one more question before we dive back into the other questions, which is, how did you come to care about Passive House? You've been an architect for quite some time. Has it always been part of your language, or is it something you added to your repertoire?
Well, I was trained in Europe, and there it's very similar to Passive House, how you detail buildings. So that's how we were taught in school. So then when I started in the United States, it was very different, that we pretty much nobody cared about having no thermal bridging, and I still cared about it. So then I ran across Fuse, and I went to the first conference in Philadelphia. I remember that. And then I really liked everybody there, and it was just like-minded professionals. So I decided to get certified, and then I sort of, what I knew before, sort of channeled through Passive House and learned even more and embraced it. Yeah, that's why.
Beautiful. Well, you've got some original Philadelphia Passive House community folks on the call. I see Paul's here. All right, our next question up is George Ostro. George, I hope I said your name right. And if you'd like to unmute, you could ask your question.
Yep, George is correct. So, yeah, thanks. I did my single-family passive house work in the Seattle area, which is blessed with like 30% humidity in the summer. That is no humidity at all. And so wondering what's the strategy for the humidity in Carolina, where it's just suffocating? Is it simple as just an ERV doing its job, or is there more to it?
It is actually really simple. So the biggest driver of humidity into the house is air. So if you are airtight, that's number one. That really, really helps. And the second thing is we do incorporate a dehumidifier to help the ERV. So you can add that too. And I would recommend just studying it better or hiring a mechanical engineer to size that equipment for you. Or you can maybe do it yourself, but that's what we have done in all the houses. We add a dehumidifier in addition to the ERV. The ERV does a little bit, and then the dehumidifier helps if needed. It can kick on.
So is that a separate, like, is it just in the main airstream of, of the ERV that
yes,
it's a desiccant
it is.
or something like that, right? It's like limestone or something that sucks the moisture out of the air and then drips away.
Oh, yeah, you could do that too. There are passive ways of getting humidity out of the air as well.
I'm not familiar with the tech, yeah.
Yeah, you can do, I know that people build steel plates, and then it would cold steel plates, and then it would condensate on it and drip down. But yes, I don't know what the technology for dehumidifier is. I just know that it's a dehumidifier. It's a mechanical box, and it extracts humidity from the air. I don't know more than that either.
That's the architect answer, and I love
it.
Yeah. Thanks.
Thank you, George. Yes, it always depends, right?
Yeah.
And, I know I saw that condensation strategy used in a project that needed water. It was a living building challenge project. So they actually designed the roof to condense so they could collect the condensation and use the water. It's just brilliant. I also noticed you had a 3D, it looked like a 3D model in your set when you were paging through.
Yes.
Of the mechanicals. And I'm wondering, what did you do your drawings in? How did your subs collaborate? Did they collaborate in 3D, or did you model their work in 3D in order to understand, clash detection or anything like that?
Okay, so we did not model the mechanical in 3D. Maybe we did only where we had the round exposed ductwork, just to see how it looks aesthetically, what the size is. Maybe we have done that. But we work in Revit, so that is a BIM software. And we like it because it's great for design, because you can quickly see how your project proportionately looks like, and you can set the right geolocation, and you can turn on shadows and see how that all works. So that's really easy to work with. On this project, our mechanical team used 2D CAD. They can use 3D too, but on this they use 2D, and structural uses 2D only. But he's old school, he's very good. So he doesn't 3D to do clash detection. So it's pretty good, yeah.
And I love using equipment that can all be underwater. I love using this boat equipment. I think it's just brilliant. I live in a river town, and our buildings get flooded, and anyone who has mechanicals in the basement, they really would like this strategy as well, especially the electrical panel if it's down there.
Yeah.
Can you talk a little bit about the hot water strategy and how you approached it?
The hot water strategy is a heat pump hot water heater, and it sits in a mechanical room that is in the first floor together with the battery storage. And what's nice about it is that it will extract heat from the room to heat the water for your hot water. And that's really a good symbiosis with the batteries, because the batteries heat up and you don't want them to heat up too much. So the batteries will give off heat, the hot water heater will take it and use it to heat your water. And another interesting thing is that we did a 2-hour rated separation, ceiling and walls for the battery pack, because the client was really concerned that they could catch fire. So we used, because I'm mostly a commercial architect, in all honesty, so I know how to do a 2-rated fire wall. So we did that for him. Yeah, like a fire barrier, 2-hour ceiling and walls. So we detailed it just like we would in a commercial project. So he has peace of mind, you know.
Great advice. Yes, as we all start to incorporate this load shifting and battery storage, fire is always a concern. So thank you for sharing that. All right, let's see. Do we have any more questions? We do. Prescott, hi, how are you? Would you like to come on and ask your question?
Sure. Hey, so my question's about DC appliances and electricity. You mentioned the lights and the ceiling fans, and I wonder if you went with anything else in the house, like refrigerator, stove, microwave, and if that stuff is even available as DC, because I know there's more people doing their van life and sort of finding small DC appliances, but I wonder if you considered it at the ordinary scale.
We did. So the fans and the lights are DC. You can also do outlets where you can plug in USB directly, DC direct current. And we had a refrigerator and a freezer that were available as DC. And I think that equipment comes from boating as well, like from yachting, you know, because they run everything DC on the boats. But we also worked on a project where the goal was to create a completely DC run house. And then I learned that a lot of the big appliance manufacturers, they are now working on DC equipment. I don't know if it's going to be for mass use or it's just like experimental at this point. But for example, LG, washer, dryer, all of that would be a DC. So the people are trying to work on it. So yeah, there are prototypes already.
Thanks for that question, Prescott. All right, well, we are just going to take a quick moment, Kristina, just stand by, to share a member story from the Reimagine Buildings Collective. So enjoy.
Yeah, thank you. Thanks, Shannon. So for those of you who don't know, the Reimagine Buildings Collective is where we bring together builders, designers, and change makers driven to create healthy, climate-ready buildings so that we can share hard-won lessons, level up our practices, and build the networks we need to thrive. So I have a quick message from one of our members.
Yeah, so I joined this Reimagine Building Collective recently because as an architect, I wanted to connect with others who have a similar interest and passion for passive house and sustainable design. I'm a certified PHA passive house designer, but you can't do this work on your own. You can't do it in a vacuum. So I would say that within my first month that I've joined, I've already gained substantial benefit from its webinars and website resources. There are typically at least 2 gatherings per week to discuss all kinds of topics relating to passive house, sustainable design issues, so forth, both at a high level and at the small detail level, getting into the weeds about how to develop good details and build better buildings, how to make them more resilient, how to get them certified. I got some street talk going on. There are some very knowledgeable people here from all parts of the country with a very diverse set of skills. And I feel that the connections I'm making are well worth my time and attention. So, lastly, I got to say that when you join this group, Zach's going to make you feel very much at home.
All right, thank you. So for more stories like that and to learn more about what the collective is all about, please visit reimaginebuildings.com. And we'd love to have you join us as a member. Thanks.
Great testimonial. Thank you, Zach. And that is a true story. Zach is going to make you feel right at home. And for those of you who joined us last week for the Reimagine Buildings Conference, Past, Present, and Future, you got a real taste of some excellent presentations and some good old-fashioned community networking. One of the other things that I love is just talking about materials. We can't know all of the materials that are coming out, so it's wonderful to be able to reach out to other professionals and say, hey, have you used this? How did you like it? What substitutions did you consider? And it's really a great resource. So I'll see you over there, maybe right after this. It looks like we have another question in the chat from Stephen Stewart. Stephen, are you with us? And would you?
I am indeed. I am indeed. Thank you so much, Kristina. What a beautiful, beautiful project. It's really inspiring how you handled the window detail with those slats. But I work with Yes Tomorrow Design Build School, which is an adult education school in Waitsfield, Vermont, and I curate the Building Science Net Zero Design course. And this year we had a tremendous debate among our students about where does the air barrier go. Some of my guest lecturers said, always put it on the interior because you want to keep that warm, moist air from actually getting into the insulation cavity. Others said, it doesn't matter. It's not going to go anywhere, even because if you have the air barrier on the outside. And, typically we're taught that the air barrier goes on the warm and winter side because you want to keep that vapor drive from the inside of the house getting into the wall. And in a heating or cooling dominated climate, you want to put the air barrier on the outside so that you can address the vapor drive that would be coming from that warm moisture trying to get into a cooler interior. How did you arrive at where you placed the air barrier?
I did a lot of research. So our air barrier is inside, it is the Intello, but we also have the Mento membrane, which works as a weather barrier. So we decided to do the Intello because that was the best way to keep the air barrier continuous and that we can tape it one to another and that we really have that continuous air barrier. It works well. And we don't use Intello if we use the exterior vapor barrier. Like if we used Armor Board before, if you're familiar with it, and that has a liquid air barrier on the product already, and then you tape the joints, similar like with Zip R. And there we do not use Intello. Then your air barrier is effectively the outside of your weather barrier is the air barrier as well. In this house in particular, we did it this way because we used only fluffy insulation. So I was really worried that by attaching the metal siding that they would puncture the exterior air barrier, and it was much safer to use the interior one because it would not be penetrated by electrical conduits or anything. It was easy to install, and then in front of it we have the 2.5-inch electrical chase. So that was my reasoning, and also did a lot of research on it, that it would indeed open towards the vapor drive, so it would allow vapor to pass through if needed, but it would keep air inside the house. So that's how we arrived at it. Yeah, it was like a lot of thinking and deliberating, just like your students. Yeah, it's yeah.
Yeah, thank you so much. That I love the protection of the air barrier because that does seem to be where everyone draws the line. I can protect the air barrier better if it's here versus here. And that's what I heard. You could protect it better on the inside because you didn't want it to be punctured by the application of the metal siding. Yeah. Thanks so much.
You're welcome. Thank you for the question.
Great question, Stephen. And I do also like, Kristina, your approach to have that bidirectional vapor diffusion. So it's vapor open to both directions, which really, I think, protects you when extreme climate changes quickly and you really can't predict it. It just gives you a belt and suspenders approach, right?
Yes.
So that's very nice. But I also liked where you called out about where the boat storage was. You had the floor system there where you have to maintain that barrier, but you also don't want to prevent it from drying out when you have a leak inside, right?
Yeah, yeah.
Yeah, and that happens a lot when we have the garages, right? Inside the envelope, but outside the thermal boundary. And we have maybe a bathroom or a kitchen above them and fluffy insulation. And I think that's one of the trickiest little FIAS details where we all end up doing a little hygrothermal modeling.
Yes. Yes.
Yeah.
Very true.
Did you do hygrothermal modeling on this project, Kristina?
We did not actually.
Didn't have to.
We
Great.
didn't have to. Yes, everything was pretty clearly working, so that was good. Yeah.
Yeah, it's a very elegant design. I really like how straightforward it is. I love that the client came with the design and said, "Make it passive house."
Yeah, yeah, that was really amazing. Yeah, I don't get those clients often, but it happens once in a while.
Yeah. Well, I think this is our last call for questions. If I missed your question in the chat, please let us know. Raise your hand or give a shout. And we'll wait just another moment in case someone's got a burning question that we didn't see. Oh, it looks like Paul. Paul has a question. Paul Thompson, would you like to come on and unmute?
Yes, I'm here. Thank you. Hi, Shannon. Hello, everyone. Kristina, I have a question about the roof, of your approach to the roof. I think it was a metal roof, and then there's the solar panels on the top. Was there a vent space below the metal until you get to the thermal envelope?
Yes.
What sort of insulation did you use that? I know I have a project where we're working with FIAS and looking using a vapor open, like a wood fiberboard insulation, which triggers some question about the percentage of insulation above the sheathing and in the cavity. So I want to see how you went down that road.
So I'll just show you the detail. And yes, it was important to me to vent below the panels. I don't know. I thought they would heat up very, very a lot. Like they are black too. And with the solar panels, it's not great. So I tried. This was like my first passive house, and I was very enthusiastic and very like trying not to use any foam. There is no spray foam. Well, there is XPS under the slab, but that's I think about it. So the roof was insulated all with mineral wool. And then you have Intello as the air barrier, and that's really it. That's pretty simple. And then you just went over the beds, and that's supposed to cool the house. So it's basically like a rain screen sort of above there as well.
And so
I don't know if this helps you.
So there's you don't have continuous insulation on top of the roof sheathing. It's all in the cavity on the roof, and then it switches to
this
the
is
wall.
the
You
continuous. This yellow thing is really the continuous. It's below the rafter.
Okay.
And then everything else is in between the rafters. Yeah, and then you get some ventilation there.
And I love the vented roof approach. I just think it's so smart. And especially when you're putting solar panels on, sometimes those get very hot. So it's really nice to release that heat from that interior, sweater that we're putting on for passive house. But spoiler alert, Kristina, this is your first passive house. This is absolutely fantastic.
That was the first one, yeah.
Oh, congratulations. It's amazing. I have a nitty-gritty question. You can just say it depends if you don't have a quick quip for me in return. But I'm looking at the detail here. I'm thinking about the integrated gutter. I know it's outside the envelope in the eave, but did it interrupt your venting, or did you kind of bring it under and have an eave vent in the soffit? It looks like you had a continuous soffit vent.
I need to bring up that detail for it. It's right here. Let me see if I can share that.
Oh, you're so kind.
Yeah, sure.
That's very, very gracious of you. Thank you so much.
Yeah, this is how this worked.
Oh, wow. You're the best. This is fantastic.
It's a crazy detail.
This is why we're here. This is why we're here. This is really beautiful.
Thank you. Yeah. But yeah, and it's nice because I didn't want, standard gutters hanging off of this really nice modern house. So, and also I was really scared to put them inside of the envelope because, you know, if
Yes.
something leaks. So this was like hard to do, but it was good because now if it leaks, at least it's outside and you don't see them. So I got the best of both worlds.
And it looks very easy to clean. And if there's an overflow, it looks like it's got the direction it wants to go. I've done integrated gutters in the eaves before on very low pitches and had ice dams and had to put tracers in them. So bravo. This looks really great.
Thank you. Yeah, we don't have that problem that much with ice. Although it can happen. So it could happen. So
yeah.
that's the thing
And you
with
have good
North
slope.
Carolina. Yeah, yeah, yeah. Yeah,
Yeah.
and then also the wood you see ties in there, so it's all like looks seamless, so you don't really see the gutters at all.
Beautiful.
Nice, yeah. Thanks, yeah. Sure.
Of course. I'm going to jump back to my other screen and see, do we have any more questions? I don't see any.
We have one more that came in from Dale.
Oh, great. Hi, Dale. How's it going?
Hi, Shannon. Glad to see you on here. You guys are
You
doing
too.
good. I asked about transportation and what does the person do? They put themselves out, looks like near a bay, not a creek to me, but how do they get from place to place? I enjoy in Berlin, I use the bicycle or I walk. And here I use the bicycle. How do they go from anywhere to get from the house and back?
Yeah.
How far are they from markets and shopping or anything else they need to do? Medical facilities?
Probably 15 to 20 minutes
By what?
by car.
What kind of car?
What kind of car?
That's the point.
Maybe by boat. There is a boat, right? So
Yeah.
Yeah.
take a boat over.
Well, this is, yeah, it's more like a vacation home, probably. Then you wouldn't have school kids in here. You would probably homeschool them or something if you had kids. So it's not a situation where you want to go somewhere. Like this is more like you want to escape your city life. That's that type of home. But I get what you're saying. Also, the client specifically has a boat, so he can just hop in the boat and go by boat, actually, just across the bay.
Greta
like you
Thunberg
say.
does with a sailboat around the world, huh? But
Yeah.
you
Well,
could
I
use
don't
the
know.
home also as tax deduction for an exhibit or teaching school.
Oh, yeah.
Thank you, Dale.
Yeah.
And this is a great example of the fact that passive house people care about more than just what they're required to, right? We care about the emissions from transportation and you know, the character of living and being part of a community.
Well, the expansion over the years has been enormous. The details, the world's very immense, and it's just without this group, it would be really difficult to do things. And I like the conversation that was brought up on doing humidity. I'm looking at moving to Okinawa and getting out of here. Other places where it's, or even Cancun, where I have friends, you know, passive condensation, reducing humidity, that's a big thing. And then we can do the temperature. Temperature's easy. It's the humidity is a challenge.
Yep, and the materials, yes. All that embodied carbon. I'm wearing my embodied carbon hat today.
That's a cool hat.
Could you do
Yeah.
solar? Could you do a EV with that solar?
Yes.
And what you have?
Yes, they do it in another house in Charlotte. They run the whole house on the solar and they charge the EV cars on it, and it all ran at the same time. So yeah, it's good because the house is efficient, so you get more power to charge the
Well,
car.
the DC you put in there is really good. We discussed that a decade or so ago, but now I'm glad to see it's being done. So we have examples of people doing these things. There's no need to go from DC to AC back to DC because all our computer equipment is actually DC.
Yeah,
it's a
Thank
great
you.
point, Dale. Thank you. I think that's a great note to end on because really, if we could get back to that, think of the efficiencies. There's incredible efficiencies there. So I'm 100% in agreement.